All right. Good morning. Goedemorgen. I hope you're all awake on the last day of TechEd, early in the morning, and we're going to talk about DAX, our data analysis expressions. So we're going to look at how we can enrich your tabular models, Power Pivot and tabular models in SDT using data analysis expressions. In this session, we're going to look at what is data analysis expressions, how did it came to be, what are some core concepts of data analysis expressions that you need to know if you want to evolve in DAX. It's not as a steep learning curve as MDX is, but there are some key things that you need to know. And if you know those things, if there's one particular hurdle, if you know that, then you're off to go with DAX. So we're going to show that, and we're also going to look at some new functionality for DAX that is new with SQL Server 2012. So my name is Casper de Jonge. I work as a program manager at the SQL Server analysis team in Redmond. I am responsible for a lot of the UI in Power Pivot and SSDT and SSMS, and I have a passion for DAX. It's not really my team, but I love it and play around with it a lot. So if you have any questions, raise your hand. It's pretty hard for me to see, so you might yell out or come to me at the end. It's pretty hard for me to see in the area. So okay, let's get going. So what are our objectives and takeaways for today? We're going to look at DAX. It's introduced in Power Pivot for SQL Server 2008 R2, previous release. We've made several enhancements in SQL Server 2012. We have now, before, DAX was only a function language inside Excel and Power Pivot. Now it also can be used by IT/BI pros. Within SQL Server Data Tools and SSMS, DAX is now turning into a query language as well, slowly and gradually. The first customer that we have for this DAX as a query language is PowerView. PowerView uses DAX as a query language. It's mostly tuned for that, so we'll go into that. We'll have lots of demos. We have two major demos. One is a demo of DAX in Power Pivot, and the other one is DAX as a query language in SSMS. So what is DAX? DAX is introduced as part of Power Pivot add-in for Excel. There are two ways you can use formulas. Formulas can be used in the calculated column and in the measure. And we'll go into that much more detailed later on in the demonstration. But there are two different ways. It's the same syntax as Excel, including many Excel functions. We actually just went into the Excel code and copied a bunch of functions and pasted it over into Power Pivot. That's how similar they are. But we have a lot of capabilities beyond Excel formulas. For example, we have relationships in our model, so we can navigate them. We don't need VLOOKUP. We can just use relationships and it will automatically work. Our measures are dynamically calculated, and we'll go into that. That's one of those important things you need to know, and we'll go into that a little bit later. We have tabled valued functions. So functions usually in Excel return one value, a scalar value. We actually have functions that return a table value, and we'll go into that as well. And we have time intelligence functions. So you can do year to date, previous year, all those things without having to do a lot of hassle. You need to set up your model in the correct way, and there's some things that you need to do, and we'll go into that as well in the demo. So what did we enhance in SQL Server 2012? DAX can now be used in both Power Pivot and Analysis Services, the professional tool. We enabled DAX as a query language. We extended Power Pivot with a lot more DAX functions. Mostly were requests by the PowerView team that they needed, and we've added a few things like standard deviation and things like that to the DAX formula language. So we added functions that build data sets for reporting. So the big difference between multidimensional and DAX queries is multidimensional returns a multidimensional result set. Tabular always returns rows and filters, so two axes. Perfectly suited for reporting. We've added support for more complex data models, and we continue the evaluation of DAX expressions, the evolution of DAX expression language. So we'll keep on working on it. If you have requests of things or what you want to see, please file them on Microsoft Connect. Those things come directly into the product team, so we'll see them, and it gives us a lot of value if you guys say, we need this, please add it. And if it goes like to that route, everyone in the product team will see it. So it's a great way to get feedback. Okay, and with that, let's get started. So for those of you who've seen my 2 previous presentations, I'm trying to use the same team. I'm a data analyst, and I work at Contoso Communications. I'm currently working on exploring the fiscal year results when my boss comes storming in and he says, hey, we want to open a new store somewhere else in the world, and we want to see which other stores are doing great, so we can copy what they are doing. So which stores are that? The boss actually tried to look at our corporate BI environment, but he couldn't find the report. So now he's asking me to give him that report. So we don't have it in a corporate BI environment, so I go to Power Pivot. I go in Excel to get him this short-term business case. So what I have here is I've installed Power Pivot inside Excel 2010. So we get the Power Pivot in the ribbon. And what I've done here is I've opened the Power Pivot and I've imported a bunch of data. So we can import a bunch of data into Power Pivot. It's SQL Server, Azure, Parallel Data Warehouse, Oracle, Teradata. And we can mash up all the data. We can import that into our Power Pivot for Excel. And in Power Pivot for Excel, all the data comes together into our analysis service engine, which is running inside Excel. And we can create relationships between them. So here you see we have a whole bunch of relationships between all the tables. And as soon as we've done that, imported the tables, created relationships, we can start doing our analytics. So let's get started. The first thing that I want to do is, in our organization, when we talk about regions, we always have a specific way of talking about regions. And when I imported my regions table, I didn't get that. So I need to enhance my table, change my table to get that function. And I can do that by creating a calculated column. So it's pretty easy to remember. A calculated column is for enriching your table. It is a static result. And I'll show you in a second. So what I can do here is I can click on this field and I can add a column. So what I can do is I can just very simply equal sales territory group and sales territory region. Press enter, and now this one formula that we see up here is going to be evaluated for each and every row inside this table. And the results of this formula will be stored inside this table. So this is not a dynamic measure, not a dynamic function. So this is a measure that you will actually the result set of this will actually be stored inside this table. So whenever a user starts using it, the function will not be executed again. So it's stored inside the model. It's stored in memory. So whenever a user starts using this is going to be blazing fast because it's the same way as it would be imported from a source data. So I can rename it to region. And the only time that this data gets refreshed is when we refresh the table, so we get new data in, or when you change the formula. Other than that, it will always be there in memory. So for the user, it doesn't matter. So this is not a good place if you want to summarize things. If you want to summarize things, you should not use a calculated column. If you want to start doing summarize, you can go to the pivot table and start creating measures. So let's do that. Existing worksheet, and I can go to my sales table, and I can click on sales amount. So what happened when I clicked on sales amount? It automatically created something for me. It automatically created a measure for me. And Power Pivot and Excel now together created a measure called sum of sales amount. And this is an aggregation. This is a dynamic measure. Because the sum of sales amount is determined by sum of sales table, sales amount column. And what you see here, the value, is the entire sum of sales amount from the entire table. So there's nothing being done, there's nothing filtered or sliced or anything. It automatically gives us the results from the entire table. Now, given that it doesn't have a whole lot of tables, just 60,000, but it's still blazing fast. Even if you have many, many rows, it will be very fast because everything is in memory and it's tuned for that. So what happens when we add another value? So let's say we add, of course, our region. So here you see the region column that we just added. And it just looks like any column that we imported from the source table. So it looks like the same, and it behaves the same as any imported table. So what I can do is I can just drag in region, and voila. Now it automatically dynamically calculates the measure again for each and every region. So when I hover over it, you can actually see it. Now this sum of sales amount in this cell is filtered down by Europe, France. I didn't have to do anything. I didn't have to write a different kind of a measure. It automatically filtered down my results based on whatever's on the rows. And that is one of the important concepts of DAX. Dynamic measures are automatically evaluated and calculated for each and every field that you put on rows and on columns. And the same thing goes if you want to do it in a query. In a query, you get the same results. If you add rows and you add columns, the same thing will happen. So that's a very important concept. And you can see now that this sum of sales amount is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times evaluated. What else? Well, let's say I would put in calendar year. You now see that the same measure again is being calculated for each and every row automatically. If I now hover over it, yep, here we go. Oh. If you now hover over it, you will see that the value is now evaluated by row Europe, Germany, and column 2002. So this is important. And I can actually even look at that. So let me remove this thing because I touched some magic key. What we can do now is actually look at what the actual value is that we evaluated. I have created a measure. Let me move this to slicers because we need a little bit more room. We can remove sum of sales amount. And let's add a measure called filter context. And now it automatically shows me what is being evaluated for each and every cell. And this behavior is something that we call filter context. So what you see now is this cell, it calculates the values for Europe, Germany, all years, United Kingdom, all years, and if I click on Slicer, you will see now automatically evaluates for 2003, 2004, 2002. This is a very important concept. Okay. But what can you actually do with this? Because this is all nice and handy, but it just works, right? But you can actually use this filter context. And you can use this filter context in your advantage. So what we're going to do is we're going to add sales. And now we're going to look at, okay, the sales that we have here for each and every region, how do they contribute to the overall sales? What's the percentage of their parent? And what I'm going to do, and yesterday in the Power Pivot session I showed you how you can do it using native Excel features, but now we're going to create a DAX function that actually allows you to do that. And it's actually pretty straightforward if you think about it. So what we can do is, what we need is a measure that in each and every cell ignores the region filter. And it just calculates the sum of sales amount for all regions instead of this one region that we're filtering. So what I can do is create a new measure and click the new measure button. And it says sales all regions. And another thing that's new in SQL 2012 is our formatting options. So you can now finally apply formatting and this will be stored with the measure instead of 2008 R2 where every time you dragged in the measure you have to reapply formatting each and every time. That was quite irritating. So now we store the formatting. So what we can do is, and this is one of the most important functions that there is in DAX, is called calculate. And we're going to now tell DAX to calculate the sum of sales amount. I just referenced another measure. And I want him to calculate the sum of sales amount for all regions. And that's it. So what we're doing here is we're saying, hey, sum of sales amount, please ignore whatever you put on regions, on any filter, and just give me the sales amount for all regions, regardless of what you do. So we press OK, and now we'll see that this value is the same as here. So now we've had sum of sales amount. But the interesting thing here is it still keeps our calendar year intact. So we've only overwritten one filter. We've overwritten the filter of region. And now we can use another measure where we can do new measure percentage of regions, where I can do, and it's going to be a percentage, sum of sales amount divided by sales for all regions. Check formula. And I would always recommend you, in the end of when you are finished with your measure, do check formula here, because otherwise you press OK, and it's going to push you down to the model, and then Excel is going to give you an error message, and then you have to start it up again. So this will save you a lot of time if you are working on your measures. Always do check formula. Press OK, and now we see the percentage of all regions. I think I touched some key, so let me quickly recreate the pivot table. See, now we get the calendar year on slicers. Okay, so now we have the percentage of region here, with sum of sales amount and percentage of region. So this is how you can use filter context. You can put it into your advantage, and we'll see many more examples today how you can work with this filter context and make it into your advantage. But it's a very important concept, and as soon as you start understanding what this filter context means to you, you will be able to get a long way with DAX, and you'll be able to do a lot of things with it. So what else? Well, of course, you can still apply conditional formatting, just the normal Excel conditional formatting. Doesn't really have anything to do with Power Pivot, but makes it immediately look good. Okay, so while we're looking here at those sales amount and the percentage of regions, I was started wondering, how many actual products were being used in the sales of this? So what I can do is, and this is not a new function that we have in SQL 2012, is a function called distinct count. Those of you who have a multidimensional background will know that this is very hard to do in multidimensional, but in DAX it's very straightforward. So what I'm going to do now is I'm going to do a distinct count from the sales table on product key. And again, let me go distinct prod, and this is going to be a whole number. So the interesting thing is, so what is actually happening here? So we do a distinct count on the sales table with product key. But how does it know what is applicable? And again, what happens here is, because we use this distinct count of sales product key inside a cell, it will make sure that the filters are applied. So the sales table is automatically being filtered down by whatever's on rows and on columns and on slicers. So in this case, for each and every cell, my sales table is filtered down for the region that we're in and the year that we're selected. So we only have a subset of the sales table. And for that subset, it'll actually look at the product key column and now do a distinct count for all the values inside that product key column. Press OK. And now you see all the distinct products. And still the years are applied and the regions are applied. So now we see the distinct products. And we can actually see that those who are not doing great only sell 6 different products, while those who are doing better actually sell much more different products. Okay. What else? Well, another very important thing in any BI product and any BI question is often, so how do they rank against each other? That's another new function we introduced in SQL 2012. It's called a rank function. And I'm going to show you how we can rank each and every region by sum of sales amount by all the other regions. Because that's what a rank is, right? A rank is, I would like to rank the sum of sales amount of this particular Europe France against all other regions. And that will give me the rank.
One question to the measure distinct product. Why did you add it to the date?
So the question was the distinct product. Why did you
add the measure to the date table?
Did I? I did, yes. For no particular reason. I can move it. Let me move it. For measure doesn't really mean a whole lot where it lives. And it should be in a sales table, so that was a very keen observation. No, it doesn't really matter where measures live. They can live wherever, whatever it makes sense. And in this case, it probably doesn't mean a lot that it lives in the product table. Okay, rank. So we do a new measure, and we do rank. And rank is often, of course, a whole number. So what we're going to do is we're going to use a function called rank x. And rank x asks for a few arguments. A table and an expression, those are mandatory, and the rest are optional. And what this thing does, it asks for two things, a table and an expression. And what this thing will do, it will rank the expression that we give in here for the current context against the table that we apply. So in this case, what we're going to do is, I want to rank against all regions the sum of sales amount. And that's all there is to it. So what's now going to happen is, it's going to look at the current cell that we're in, so that's the sum of sales amount for the region that we're in, and it's going to compare that with the sum of sales amount for all the regions that we have in the first parameter. And that's all there is to it, to the rank function. So we press OK, and now we see the rank function. And of course, we can move it to the front. Move it to the front and do an order. And now we see the rank. But one thing strikes me here, because now all of a sudden this new line showed up, right? NA line. So where did this come from? Because it doesn't have any sales, where does it come from? Well, because in our rank function we set rank the sum of sales amount against all values from the region table. And in my region table, I actually have an NA column. And this NA column is often used in data warehouses when you have problems with your quality. They actually say, if, let's say we have a sales for something that we don't have region for, we often combine that to the NA column, so we make sure that we can still see all the data, but we tie it to something else. Of course, in my case, the data is so clean that we don't have any values here. But what we can do is we can exclude this row, because I don't want to see it. A rank only makes sense to me if it actually has a sales amount. Another thing that I explained yesterday in my Power Pivot session is, there are many ways to go with DAX and with Power Pivot in general. There is a way that you want to make sure that the measures that you create, if you're a BI professional and you're creating your measures for a large enterprise cube or model, you want to make sure your measures work in all cases. There's a difference between taking the pragmatic approach that often Excel users would do and the BI professional approach. So I'm going to take this in the pragmatic approach. What I'm going to do is I'm going to say, if not is blank, sum of sales amount, do rank X, otherwise do nothing, return blank value. So what will happen now is it will actually go and look when it evaluates this measure. If we have a sum of sales amount for this region, if we don't have a sum of sales amount, we return blank. And blank is always excluded by Excel by default. You can turn it on in the pivot table if you want to, but blank is by default always turned off, meaning don't show the row. If you want to do it, so DAX has many ways to solve one problem. This is one way. You could go in and now start combining all kinds of different filters where you want to see where you filter down the regions table, where it only has values, but that's going to be very complex. So I usually try to go for the most pragmatic approach. Press OK, and now we see the rank is actually being here. And the cool thing is, those functions just work. Whenever I click around in the calendar year, we see it now automatically change. So here we've seen, for example, United Kingdom come in. Here they swap places. So it's automatically calculated each and every time I change the values. OK, so let's continue our investigation. Let's create a new pivot table. Let's create an existing workbook. And let's start by dragging in sales amount. For those of you who haven't seen the new function in Power Pivot, what you can do here is search. And you can search all the columns that you have in your table, and you can just drag them in. In this case, I'm going to drag in sales amount, and now it gives me sales amount value of 29 million. Well, I would have expected it would be 9 million. Does anyone have an idea why I have 29 million here? Yes. So a small tip. What you can do in the pivot table is we have a slicer here, and by default it's not connected to this slicer. When you create a secondary pivot table or charts or anything like that, they're not connected to the pivot table. Only the first one where you actually dragged it in. But what you can do is you can connect any pivot table against a slicer. So what I can do is go to Options, Insert Slicer, and I could insert a new one, or I can add connections. And this is just native Excel behavior. It has nothing to do with Power Pivot, but it's an interesting approach. So I'm going to add it to the sheet 2, which we're currently in. Press OK, and now we see 9.7 million show up. And now everything shows up here. OK, so let's add region back. And the thing that I now want to be able to see is, so we see some of sales amount for all products, but we just have seen that some of them have actually 133 products, different sales, and others have only 10 products that they use. So what is the sum of sales amount for our top 10 best-selling products? And that's another function that we introduced in SQL 2012, a top N function. So what we can do is create a new measure. And now we're going to do top 10 sales product. I'm going to use a currency. So what we're going to do now is top N. And it takes a whole bunch of arguments. Top N, the N value is the number of rows that we want to have returned. We have a table and an order by expression. And we can order it on as long as we want to go to. In this case, we're going to keep it simple. Top 10 products sorted by sum of sales amount. And this will automatically give us the top 10 products for sum of sales amount. But it's going to automatically do it, again, by using the filter context. So in the region that we're selected, it's going to give us the top 10 best-selling products for this region and the year that is automatically filtered. But if you do check formula here, we get an error. It says a calculation error in measure, the expression refers to multiple columns. Multiple columns cannot be converted to a scalar value. And this is also an important concept. Because in DAX, in the formula statements that you want to use inside Power Pivot, every function that you have in here needs to return only one value. And here, top N actually returns a set of 10 different products. It doesn't even give me sales amount. It just gives me a set of 10 different products. So now we need to do something. We need to aggregate these 10 different products. And we have other functions that you can use to aggregate a tabular result set. Because that's what happened here. You have just a table of 10 different products are returned. So what I can do is I can use a function called SumX. And SumX takes two arguments, a table and an expression. And the first argument of the SumX function is the table, and the second one is the expression. And what it does is it aggregates the second expression for all the values in the first table. So in this case, what we're going to do is we're going to say summarize those top 10 best-selling products by sum of sales amount. And that's going to return only one scalar value. So we do summarize top n functions by sum of sales amount. And so another interesting thing that you might notice here is it asks for a function. So you can do two things. You can either write some bracket open and then a column, or you can reference to a measure. It doesn't really matter. What I always try to tell people who start writing DAX is split up your measures. Split them up as much as you can, because that gives you a very good way of debugging. Because right now, if you have one big table, one big expression, it's going to be very hard to see, because this is a demo. Everything works immediately perfect. But in the real world, you probably will not have the results that you expect. So you need to have a way to debug into it. And if you split up measures, you can actually see them. One interesting thing that I can show you, and let's continue on this, SumX top 10 products by sum of sales amount and aggregate them using sum of sales amount. So we press OK, and now we see the top 10 sale products. But those sales are actually all here. So what I can do is I can actually start hiding measures. Because if you split them up a lot, you will see a lot of measures in here, and you might not want that. Another thing that you now can do in SQL 2012 is you can go to the Power Pivot table, you can go to your regions, and you can start hiding things. For example, I could now, for example, the distinct product measure, right mouse click, hide from client tools. And now it has hidden this measure. And if I do refresh here, it won't show up anymore here. I can still use it and reference it in other measures, but it won't clutter the field list. So that's another interesting thing that we can do. And one more thing that I want to explain a little bit about is this is our calculation area. And many BI professionals don't really like our calculation area because it doesn't give them a lot of opportunity to write large measures, and it is not very effective. Let me give you a little bit of background on what the calculation area is. So some of you who were in my other session on Power Pivot have heard it already, but a lot of Excel users were very confused when they first started writing DAX on where should we start writing. Because what they often did is, and they're very used to this kind of a view like the same thing in Excel, right? You see a similar view. And what they started doing is they went to the right, because we didn't have this in V1, right? So the only thing that they saw is, okay, I can start typing here. So they started typing measures, the dynamic measures, as a calculated column. And what happened is, if you do sum of sales amount and you start writing it here, it's automatically aggregated for each and every row inside this table. If you then use it in your pivot table, it's going to aggregate again, and you get very strange results. So a lot of people started just writing here. And we did a lot of usability study on those Excel users. We brought them into our lab, and we started doing, okay, if you were to write an aggregation function, what would you do? And the first thing that many of them wanted to do is just click on sales amount or on total product cost and just click sum. Because that's what they do in Excel. And the other part wanted to just start typing at the bottom, because that's where you do summarizing. So this measure grid is very open and free form for mostly for the Excel audience, because that's what they get. And it's very open form. You can copy and paste. You can start typing comments, whatever you want in here. It's really free form. Copy, pasting, all those things are here. That's a little bit of background on the calculation area. Many BI professionals don't really like it. Excel users now start understanding what's the difference between calculated columns and measures. Okay. So we have our top 10 sale product, and what I can do now is, okay, it asks me to refresh. It's okay. What I can do now is again calculate the percentage. So let's calculate the percentage. And we do the sales top 10 sales product divided by sum of sales amount. And again, it's going to be a percentage, check formula, percentage top 10. And what we now see, and that's very interesting, is that our top 10 best-selling products actually give us a lot of our sales. So 33% of all our sales are actually being done by our top 10 products. And we actually had 103 different products. So that's quite interesting. Okay, so let's continue our investigation. I want to see the sales by year. So let's create a new pivot table here, and let's start doing that. So the first thing that I want to do is add my date table, get on the year. But now I don't want, so what do I want to see? I want to see the sales for current year. I want to see the sales for the previous year. And I want to see the comparison between the two. But what I don't want to do is, I don't want to create three different measures. I'm going to create one measure that automatically determines what it needs to do. For those of you who have worked with multidimensional, this is what we called with the helper dimension, and you automatically created MDX function based on what's in the helper dimension. And this is a similar concept. And this is very powerful and gives you a few insights into DAX. So what I've done here is I've created a table inside Excel that says current year, previous year, and year-over-year growth. And what I've done is I clicked on Create Linked Table, and this added this table to Excel, to my Power Pivot model. So here's date type, and now added it, so now I can add this to my pivot table. Go back to sales by year, and now we can drag in date. And here we are, current year, previous year, year-over-year growth. Now I'm going to drag in a measure which I already pre-created, and we only see the current year. So we have a problem. It's not working as I expected. So what's going on here? Let's go back to our model. Because I've used time intelligence functions, and there are a few things that you need to do when you want to use time intelligence functions. So the first thing is, I've done sum of sales amount. And sum of sales amount is in my fact table. This is the sales table. And it has a relationship with the date key. And that's okay, that's exactly what we expected. But as you see here, in my relationship between the date key, it's an integer value. It's a surrogate key. And that's just very normal in any data warehouse, right? We never have dates. We always have surrogate keys, different keys. And this is an integer value. But DAX, enabled for him to use time intelligence functions, it needs real dates. Real dates. And it doesn't understand how to traverse back in time. How does it know how to do -1 year on this integer value? It doesn't. In SQL Server 2008 R2, the only way that you can get time intelligence functions to work is have your fact table have a real date column that is linked to a timetable. In this case, we don't have it, but we can fix it now. So we can go to our date table. And here we see this is the date column that we use as a primary key. Here we have the actual date column. So there are two things that you need if you want to do time intelligence functions. Two important things. You need to have a date table. The date table needs to contain continuous date range. So this means all dates of the entire year need to be there. Because what DAX actually does, it does the sum of sales amount for a particular year, month or day, and then it starts subtracting or adding dates. If it cannot find that date inside the model, it will just ignore that value. So you can get strange results. So you need to have a continuous date range. All the dates need to be there. And the other thing that you need to be able to do, what you now can do, is go into design, and here we have a mark as date table. So we can mark this table as date table, and you now get an opportunity to say, here is my date column. Press OK. Now when I go back, DAX knows where it can find an actual date column. That's what it can use to do previous year. And now we have current year, previous year, and year-over-year growth. So that automatically showed up now. So what does this measure look like? Let's go to my ordered sales measure, edit it, and let's take a look. So what I've done is I have used many different other measures in here. So I've created one measure which references other measures. And we'll go into those other measures in a second. But what I've done here is, the first thing that I've done is, I have a check that says, for the current cell that you're executing this measure, does it only contain 1 year and type? So let's say you select three years, or you don't have any years put in rows and on columns. How can it go back 1 year? What does it need to do? So it's some logic that we have here. And the other thing is, if you don't have a type selected, so current year, previous year, year-over-year growth, what should it calculate? So this measure only starts working if you have 1 year and type selected. And we'll go into this measure in a second. Otherwise, it will again return blank. So what we're doing here is we're using a switch function, and that's also new in SQL 2012. Before you had to do nested ifs, now you can have one switch, and this switch value asks for the values of date type column. And values of a column will return all the values that are there in the current context. So in this case, it will return current year or previous year or year-over-year growth. It just looks at the value, and because we have this on our rows in the pivot table, it will actually return this value. So in this case, it will return current year. And current year, we just use our sales amount function. Previous year, we use our previous year function. And for the year-over-year growth function, we use, if not, is blank previous year. So if you actually have a previous year, then subtract one from the other. So that's pretty straightforward. So let's start looking at each and every individual function. So the one that I have here is 1 year in type. So do right mouse click, edit formula, and this is very straightforward. And this is another new function that we have in SQL 2012. If has one value, date table calendar year. So this will actually look at the current cell and return true if it only has one value, and return false if it has more. Previously you needed to do if count rows of values is larger than 1, return or 0. It was very complex. Now it's much easier. If has one value, date table calendar year, and the date type only has one value, return true. Otherwise, return false. So that's a pretty straightforward, that's the helper function that I use. And again, I would recommend you using this. Okay. So for example, if I would drag this in, you will see true, 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 and the grand total returns false. So this means that my function, that's why you don't see any values here in my ordered sales for the grand total, because it is false. So let's drag this off. And the other function that we used is our previous year. Edit formula, and this is one of the time intelligence functions. So what I'm doing, and again you will notice that we use calculate here, because we're again using a form of filter context. So what we did here is calculate the sum of sales amount, but instead of using the current date that you have in your table, go back 1 year in time. So it uses that other timetable to go back 1 year in time, and then it finds the actual sum of sales amount that are part of that same date 1 year ago, and now start summarizing that. We have many time intelligence functions. This is just one of them. And I could have used a previous year function, but that was a little bit too easy. So we have previous year, previous month, previous day. We have functions called total year to date, total month to date. A lot of those things are time intelligence functions, and they're pretty easy to do. Okay, so that's it for the previous year. Okay, so what else can we do? Well, as you might have noticed, when we go back to our diagram view, is that we actually have 3 lines running between sales table and date table. And that is also new in SQL 2012. So we now have 3 different types of relationships. We have a solid, an active relationship, and inactive relationships. So we have 2 types, active relationship and inactive relationship. And the active relationship is the one that's automatically being used by Power Pivot and by Excel. So if you drag in tables, if you drag in columns, it will automatically follow and traverse the active relationship. The inactive relationship can only be used by DAX. So if I click on it, you will see that active is not checked, and here active will be checked. So you can change that if you want. So let's look at, instead of order date key, let's look at the ship date key. Let's use the same function that we just had, but now for a ship date. So let's drag in shipped sales, and it's kind of hard to read. Another small tip that I can give you, which is also new, you can now drag the values, the measures, to row. So this makes it a little bit better readable. So now we have ordered sales and shipped sales, and you can see that both of them are different. So what did I actually do to use them? Right mouse click, edit formula. And what I've done, I've just copied and pasted my entire measure. And now instead of using sum of sales amount, I've actually done calculate sum of sales amount, but now use another relationship. Use the relationship between date table date key and the sales table ship date key. So now to calculate the sum of sales amount, not using the active relationship, but using that other relationship that we created. And this is the way that you can use inactive relationships. It's different than what we had in multidimensional, where when you have multiple relationships, it automatically created multiple dimensions for you. That's no longer the case. That's not what happens here. This is just only working in DAX. And to be honest, when I was working on this measure, I actually discovered that it kept me even much more easy. Because what I did is I copied the actual formula and pasted it around. And what I can actually do is remove this guy, add a new measure, and just do calculate ordered sales. I can just completely use the other measure and do use relationship, dim, date, table, time, full date, alternate key, and sales, shipped date key. So what I'm now doing is not even copying all the rows and all the cells. I'm just calling this other measure that we have. And now saying, for this measure, always calculate using the use relationship. I actually found this out last night. And I've done this session a few times before, and I never thought about it. Need another bracket. Okay, it should work. Let's not go into too much details now, but it should work. Okay, so we have a shipped sales, we have an ordered sales key. There's one more thing that I want to dive into. What I want to dive into is, let's look at our sales by whoever did it. So let's go into our model, and let's look at the date diagram, and let's look at our employees. And I want to actually be able to find the employee that's responsible for a lot of our sales. But I want to be able to drill down. So what we have in here is two columns that says employee key and parent employee key. So what we have here is a parent-child relationship. In multidimensional, that was pretty easy. You just drag parent-child relationship and it would just work. Unfortunately, we don't have this in Power Pivot and DAX. Although there are some problems in multidimensional with parent-child when you have a large dimension table, it will take up a lot of your performance. This is going to be blazing fast, although it's a little bit more work. So what we need to do is create a DAX function. Let's go to the right because I already prepared it. And what we have here is a function called path. What we need to do is create a calculated column that creates a path between the current employee and its parents. So I'm using a function called path that says create the path between the employee key and its parent employee key. And this will automatically go all the way up the self-referencing relationship and create a calculated column that creates this path. So the great thing about this is the self-referencing relationship is now automatically stored inside the model. So whenever a user starts using this, it's going to be blazing fast because it's all in memory. It doesn't have to re-evaluate every time again. The downside is if you were to add another level to it on the fly, this trick won't work and you need to add manually another column. So that's the downside. There's an upside and a downside. So now we're going to use this path because this is not something that my users can use. And I have created 5 different calculated columns with levels. So what I'm doing here is I'm using a path item to get the first item from the path, which is the big boss. But I don't want to show, because path item 1 will return 112. I don't want to return 112 to my end users. I want to actually show them the name. So what I have used is another function that we introduced in SQL 2012, lookup value. And lookup value is kind of similar to VLOOKUP in Excel. It's a little bit different. But what I can do is I can look up any value in any table, regardless of relationship. So in this case, what I'm going to do is look up my last name, where the employee key is equal to the first item returned from my path function. In this case, it's going to be lookup value, last name, where employee key is 112. And that will return Sanchez to me. So I'm actually looking up a value in the same table that I'm in. But I'm actually looking up a value with somewhere else in another row. And I've just copied this formula a few times over. So the second level goes to path item 2, 3, 4, 5. So now I've created all those calculated columns. What can I now do with it? Well, I went back to my employee table. Let's open it up, maximize it. And I've created a hierarchy. And I've hidden all the other columns. So now let's go in. And go to employee. And here we are. Employees, drag them in. Let's look at the sales per employee. Great, 29 million. Let's drill down. There's something not completely right here, right? All my employees have the same sales amount. So we have a problem. And actually, PowerPivot is already telling us that something's not correct. Relationships may be needed. So something wrong with the relationships. Let's go back in and look at our model, what's actually wrong. And those of you who have been really paying attention might already see it. But what happens here is we have a sales table and we have a regions table. Many sales, one region. We have an employee table and we have a regions table. Many employees, one region. So what we have here is a many-to-many problem. What I'm going to show you very briefly is that we can solve the many-to-many problem using DAX, not using modeling, but using DAX. If you want to know more, there was an excellent session by Alberto Ferrari on many-to-many. I would recommend you going there because he spends more than an hour on just this topic. I'm just going to briefly talk about it. It's already online, so you can already watch it. If you want to know more details on how you can do it. But I'll quickly show you. So what I've done here is sum of sales amount per employee. Let's drag it in, 29 million. And now we can see it actually works. So we've worked around this many-to-many. So what does this measure actually look like? What I'm going to try and do is get those two next to each other. It's pretty hard in this resolution. And edit formula. Yeah, that doesn't work. So what I've done here is calculate sum of sales amount. And we've played a little trick. We've not just done sum of sales amount. What we've done here is summarize the employee table, summarize the employees, and return the real region sales territory key for those employees. So what actually happens here is we have the filter context of employees, right? Employees are on rows. So what we've now asked DAX to do is to summarize the employees table and return the sales territory key for those employees. And that's what the problem lies in this formula, because what we have here is DAX is only able to traverse one relationship if it's many-to-one, and not many-to-many. So what it can do is it can do sales, it can do regions, but it cannot traverse this guy because it totally doesn't understand. But what we've done here, we've tricked PowerPivot and the model to actually, using the summarize, we only return the sales territory key for the current employee that we're in. So now automatically the regions table is filtered, and now we get the right sum of sales amount. So as I said before, this is a pretty complex concept, and it really takes an hour-long presentation to explain it. I just briefly touched on it, that we can actually do it. I would recommend you, if you want to do this, go watch their session. It will explain this in much details. Okay, and so far for the Power Pivot side of things, let's go back to some slides. So far there was Power Pivot for the IW inside Excel. Now we have DAX for the BI Professional. And DAX was introduced in Power Pivot for Excel, but now we have SQL Server data tools that now support multidimensional and tabular models. I had a session yesterday on tabular models. If you missed it, it's also available online, and this shows you where you can actually create your tabular models. DAX can be used in SSDT as a formula, and it can be used in SSMS as a query syntax. It also can be used in our row-level security, and I showed this as well yesterday in my Tabular session. You can do dynamic security with Tabular. We again exposed the username and custom data functions in DAX. They're also available in multidimensional, so it's kind of the same concept. It's a little bit different formulas, but they're both available. So again, in my session yesterday on the Tabular model, I showed how you can do dynamic security. So what is our BI semantic architecture? And again, we briefly touched on this yesterday, but what happens now is we have two types of data models. And each type of data model can be connected to by client tools. So we have reporting services with Power View and SSRS. They can connect to it. And both of them talk a different language. One is MDX and one is DAX. Excel talks MDX. Power Pivot can also connect to the BI semantic model, and it connects with MDX. SharePoint Insights, Performance Point, those things talk MDX. So our BI semantic model is two different data models with two different query languages. And what we try to achieve is to make them interchangeable. So everything we've just shown you in DAX formulas can actually be referenced inside an MDX query. So we try to interchange them. So you can use, and actually the way that Excel talks to the embedded Power Pivot engine is using MDX. So that's interesting. The only problem is right now, we haven't completed this vision. Because you can connect with Excel and Power View, MDX and DAX to the tabular model. And it both is understood by the tabular model. The other way around is not true. If you connect to a multidimensional model, you can only talk MDX, not DAX. We are working on that. I don't have a timeline for you yet, but we are actively working on it and still committed to do it. When we achieve that goal, you can send DAX queries to a multidimensional model, and you can also connect to Power View to multidimensional. So that's in short our BI semantic model architecture. So now let's go look at querying the BI semantic model with DAX. So we have DAX query results. They're always returned as a table. And this means a row set. SQL Server 2012 adds DAX function that return tables. Usually, and that's our statement for now, users won't author queries directly. Power View will send them and automatically create them for you. Although we already see this is changing. People are starting to get a grasp of DAX's query language and start using it in their custom tools and things like that. Because the same way as you can write MDX in your custom application using ADOMD.NET, you can also use DAX queries. And there's a big request for users who want to start using DAX queries inside the reporting services reports. Because it's just a match made in heaven. It's just a tabular result that you get into a reporting service. It cannot get much better than that. So what does a DAX query look like? There are a few things that we can do in DAX as a query. We can define a measure on the fly. In the session that you're creating your DAX measure for, you can define the measure and evaluate it immediately. So this measure is not stored in the model. This measure is stored in this session, in the query that you're sending. And you can evaluate a DAX tabular expression. And evaluate is the keyword here. Where we had select in multidimensional, you now have evaluate. Evaluate a tabular expression, and you can order this tabular expression by adding an expression, ascending, descending. Okay, let's go ahead and take a look at it. So what I've done here is I've opened up SSMS, and I've actually opened a DAX query.mdx script. And you might say, oh, he's showing DAX in an MDX script. So that's what we have right now. And because our engine is smart enough to actually see what kind of a query comes in, it will actually return it into the right path. So I can create an MDX script, and you can see that now automatically returns our multidimensional view of the tabular model. But I can actually just send out queries. So in this case, I'm going to start very simple. And the case that I have here is, so I've created this tabular model. I've created all kinds of functions. It's been running for a while now. People have started complaining that there are some wrong results. It is now running on the server. We have refreshed it a lot of times, and it's different values in our production system than we have in our development system. So I need to send some queries to the production system to get down to what data is wrong. So the first thing that I want to do is just, and this is the same model that we just created, and now upload it to the server, and now let's start working on it. So the first thing that I want to do is evaluate the table. So I just did evaluate and use the table name. I can execute, and this will return a tabular result for the table name. Before we continue, there's another big difference between MDX and DAX as a query language, or DAX as a function language. MDX returns values as variants. You never can depend on MDX to return to you a decimal value, a numerical value. It is always kind of vague, because you can have MDX return a string in the middle of all your integer values or decimal values. In Power Pivot, this is not possible. Power Pivot and the tabular models are strongly typed, just like SQL Server is. So all the values that are returned here are made sure of that they are strongly typed. And the same thing goes if you want to use it in code, if you want to use it in those kinds of things. You always know for sure what the data type is for. The other difference here is because MDX returns to you the values already pre-formatted, if you know how to listen to it. So if you have a currency, it will return to you with the currency symbol and things like that. DAX will never do that. So you have to work on your own. You need to discover what the actual format string is and apply that. We use .NET format strings, so they're one-on-one compatible. So I've evaluated this table here. Now I want to filter them down. So what I'm using is an expression which is actually already there in 2008 R2, filter. So what I'm doing is evaluate a table result, in this case regions, but filter it down where the sum of sales amount is larger than 20,000. So only if the row for sum of sales amount has more than 20,000 sales, then return the result to me. So evaluate, and now we see less results. So we filtered this down. But I don't just want to show regions, I also want to see products. So what we have here is a function called cross-join. And what cross-join will do is it will, same as in SQL Server, it will take each and every row for the regions table and combine it with all rows of the product table. So we'll cross-join them together, and the table that is being returned from that. So this gives me a big table with all the regions and all the products combined, and that result will filter down. So if the combination of regions and products together have a sum of sales amount larger than 20,000, then show it to me. But this is such a big table, it doesn't give me a lot of information, right? I'm trying to get to the core of the problem here. So we're going to filter it down. So what I'm going to do now is a few things. First of all, I don't want to cross-join the entire table. I just want to cross-join two columns. So in this case, using the values function, I can say, because values also returns all the values from this particular table. And right now we haven't set any row context, so we'll always return everything. So this will return all the region values inside the region table. And we cross-join this with all the English product names. We again filter it by sum of sales amount. And each and every of these functions return tables. So first we have a table that gives me the results of the cross-join. Then we filter that table down. And then we add a column to this table. And the column contains a measure, sum of sales amount. So now we'll see region and product name with the actual sum of sales amount that they had. And now you see it becomes much better, much more readable. So we see regions, English product names, and the sum of sales amount. Of course, there's more to it. So what else can we do? For example, give me the top 5 best-selling products by sales amount for each and every region. So another function that we have is generate. And generate will generate the secondary formula, the second argument, for every value in the first argument. So this thing will go ahead and look at all the regions in my region table that has been returned, and it's executing the secondary formula for that. In this case, it will always return the top 5 English product names by sum of sales amount. I'm going to do evaluate, and now we see 5 times American Northwest with the 5 top best-selling products. And of course, we can add to it, right? We can now do add columns and add the actual measure in there. We can build on top of it, so we can enrich this table. In this case, I'm left it a little bit more simple. And this is the function that we think will probably be used most. This is a summarize function. So what we have here is evaluate, summarize the sales table, group on English product name, group on calendar year, and for those results, show me the sum of sales amount. So this is a very easy way to get a result set. And this is very easy to use in your queries, for example, that in your reporting services. The interesting thing here is, for those of you who know how to write SQL, in SQL this is pretty complex. Well, you need to write inner joins and things like that. Here, we now used values from three different tables. I didn't have to do anything. I just say, give me this field, give me this field, give me this field, and give me the sum of sales amount. And it just did it for me. Why? Because we have all this metadata in the model. The model knows how these things are related. So we automatically know what we need to do here. So this is pretty straightforward and this is pretty easy. This is a very interesting function. It can be used in many, many different cases. So for example, as you saw, I solved my many-to-many problem using summarize as well. So there are many tricks that you can think of inside Power Pivot functions for using these functions as well. And of course, we can order these results as well. So in this case, I'm ordering by calendar year and total sales descending. The rest is just still the same. And now we see 2001 is first, and the top sales are on top. Let's scroll down. You will see them. Okay, and the last thing is we can define our own measure. We can do sales gross profit equals sum of sales amount minus total product cost. I don't have this measure in my model. I only want to have it in this query. So what I'm going to do is define it on the fly and use it again in my summarize function. So I've added it here. I execute, and now we see the value is in here. So this measure is not stored in the model. So if you go back to the model and use it another time, it won't be there. It's only in this particular execution. It's not a session-based measure either, so it's not kept alive in this session. It's only for this query execution that it lives there. Okay, and so far DAX queries. Let's go back to a few more slides and then we're done. So what did we see? DAX was introduced in Power Pivot, 2008 R2. We have many DAX enhancements in SQL Server 2012. IT pros can use DAX analysis with SDT. We've seen demos of DAX in Power Pivot, seen demos of DAX as a query language. So now you can use DAX in many more scenarios. Some related content. First one is the many-to-many relationships in BIS and Tabular. Very interesting session by Marco Russo. Building self-service BI applications using Power Pivot. This is a general introduction to Power Pivot. Another very interesting session is a session by Marco Russo, BIS and multidimensional versus Tabular. He's showing much DAX in there as well, where you can, for example, see how he solves Pareto analysis, things like that in DAX. And he actually goes out and shows that many concepts that we first thought were going to be very much more useful in to create a multidimensional are actually very easy to solve in Tabular. and much more performant. So it was even a surprise for us. And the last one is optimizing your BI semantic model for performance and scale. So all of these sessions have actually already been done. So you can see them online, but the last one actually goes into many details on what is actually, how the data is stored inside the model. What happens when you do processing? What happens when you do querying? What happens with the memory usage and things like that? So it's a very interesting session if you want to know more and deep inside the VertiPack engine. Okay? If you want to get hold of me, if you have requests, questions, send me an email or go to my powerpivotblog.nl. I have a Twitter account. You can find me on Twitter. Send me an email, tweet, whatever you want to do. Let me know. And the last thing that I want to ask for you is please fill out the evaluation. We would very much like to hear from you what you think about this session and what are your comments. And with that, let's start doing some questions. Any questions? No questions? Everything was clear? Okay, good. I'll be around here until I have my next session, so you can track me down. Thank you very much for your attention.